So continuing our discussion of basic differentiation rules, we're going to look at the constant multiple rule. The constant multiple rule is basically what happens when you have a constant times a function that you know the derivative of. So if f is a differentiable function and c is a real number, then c times f is also differentiable, and the derivative with respect to x of c times f of x is equal to c times f prime of x. So be careful, because this only works when c is a constant number. It can't be a variable or contain a variable. So the way this works, we've got the derivative with respect to x of negative 3 times x squared. You can just take this constant c and bring it out front. So that would be negative 3 times the derivative with respect to x of x squared. We know how to find the derivative of this using the power rule. That would be 2x to the 2 minus 1, or 2x to the first power. And then we can just multiply our constants at the end, so that gives us negative 6x. All right, and this one, I would want to pull the 4 out first, so that would be the derivative with respect to x of 1 over x squared, or 4 times the derivative with respect to x of x to the negative 2 if I want to use the power rule. So that would be 4 times negative 2 times x to the negative 2 minus 1, or 4 times negative 2x to the negative 3. So that would be negative 8x to the negative 3, or negative 8 over x cubed. And you may vary slightly in the order that you process some of this algebra. That's perfectly okay. Let's do one more of these. I've got 2/3 times the square root of x. So I can make that the derivative with respect to x. We'll put the 2/3 on the outside of x to the 1/2. So we've already worked this problem, but we'll show it again. It can't hurt. So that would be 1/2 x to the 1/2 minus 1, or 2/3 times 1/2 x to the negative 1/2. Simplifies to be 1/3 x to the negative 1/2, or 1 over 3 square root of x in this case. The next rule is the sum or difference rule. This just tells us that the sum, or the derivative of a sum, is equal to the sum of the derivatives. The derivative of a difference is equal to the difference of the derivatives. So basically what that means is anything that's added or subtracted, we can go ahead and take the derivative of as well. So in this case, I've got the derivative of 3x squared plus 12x plus 1. So I could split this into 3 separate derivatives. So that would be the derivative with respect to x of 3x squared, plus the derivative with respect to x of 12x, plus the derivative with respect to x of 1. And then I could bring the 3 out of the first one, and the 12 out of the second one. And this one's just a constant. So this will be 3 times the derivative of x squared is 2x to the 2 minus 1, so just 2x. The derivative with respect to x of x is 1, and the derivative with respect to x of 1 is 0. So this just ends up being 6x plus 12, and that is my answer. Now, as you get more comfortable with this, you will naturally show a few less steps. That's okay. Just remember, the more work you show, the more partial credit you can get. Now this problem has a little bit of a trick up its sleeve. You are going to have to do a little bit of work first. So the first thing I would do, notice we're dividing by a monomial. I would make this 12x to the 4th over 2x minus 2x cubed over 2x plus x over 2x plus 1 over 2x. Anytime you can use algebra to simplify your life, go ahead and do it. So in this case, we would cancel here and leave a 6 and a 1. We would cancel an x and make that x cubed. The 2's would cancel. Here we'd have x squared. The x's would cancel, and in this case nothing cancels. So this simplifies to be 6x cubed minus x squared plus 1/2 plus, we're going to make this 1/2 x to the negative 1. So f prime of x, we can take the derivative of each term. That's the derivative with respect to x of 6x cubed minus the derivative with respect to x of x squared plus the derivative with respect to x of 1/2 plus the derivative with respect to x of 1/2 x to the negative 1. And if you need to go ahead and bring those powers out, or sorry, those constant multiples out, you can. If you don't have to show it. That'll be 3x squared times the 6 minus 2x plus the derivative of 1/2 is 0 plus 1/2 times negative 1x to the negative 2. So that ends up being 18x squared minus 2x minus 1 over 2x squared. When you simplify that, you don't necessarily have to find a common denominator for this problem. In the future, there may be some contexts where it would make sense to do so, but for now, you can leave it like that. We also have the derivatives of sine and cosine. The derivative with respect to x of sine of x is equal to cosine of x, and the derivative with respect to x of cosine of x is equal to negative sine of x. Now I'm going to show you a proof of the first version. It does involve a trig identity. You need to know that sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b in order to do this problem. So to prove this, we're going to let f of x be equal to sine of x. So the derivative with respect to x of sine of x is going to be the limit as h approaches 0. F of x plus h in this case is sine of x plus h. And that's going to be subtracting sine of x all divided by h. Here's where the identity comes in. Sine of x plus h is going to be sine of x cosine of h plus cosine of x sine of h minus sine of x all divided by h. Okay? And here, instead of actually factoring something out, we're going to split this up into two limits. So we'll make this the limit as h approaches 0 of, we'll take this middle part right here, that'll be cosine of x sine of h divided by h, and then we'll have the limit as h approaches 0 of, we'll do the other two parts here, sine of x cosine of h minus sine of x all divided by h. And because we're taking, let me go one more step. The limit as h approaches 0 of cosine of x sine of h divided by h. And then we'll make that the limit as h approaches 0. I'm going to go ahead and factor out the sine of x. Okay, now we are taking the limit as h approaches 0. So according to this limit, it doesn't really care what happens to x. We're only talking about what happens as h approaches 0. So in this first one, I can pull out the cosine of x. So that'll be cosine of x times the limit as h approaches 0 of sine of h over h. And in the second one, I'm going to pull out the sine of x. So that'll be the limit as h approaches 0 of cosine of h minus 1 over h. And hopefully these look familiar to you. These are the special trig limits from chapter 1. So this is cosine of x times 1 minus sine of x times 0, which is just cosine of x. Now this is not something that I would necessarily expect you to be able to do on a test, but it is something that's important to be able to understand where these rules come from. They are coming from the limit definition and other properties of math that we know. So the derivative of sine and cosine is something that you really want to commit to memory. It's something that you want to take to heart because we're going to build on that quite a lot over the coming sections. So let's look at some examples that use this. The derivative with respect to x of 3 sine of x, that would be 3 times the derivative with respect to x of sine of x, which would be 3 times cosine of x. That would be your answer. And for the second one, we could say the derivative with respect to x of x squared minus the derivative with respect to x of cosine of x. So the first derivative is 2x. The second one is negative cosine of x, so be very careful with your negatives there because they are going to end up canceling each other out. So I get 2x plus cosine of x as my answer.